all the arrangements with or without meaning of the word farmer are written, excluding any words that has two R appearing together. So we are creating only those words in which two R are not together, and then these arrangements are listed serially in alphabetical order as they are written in dictionary. So then the question is, what is the serial number of this word, right? So this is an example of dictionary problem, but there is one additional condition that here we are creating only those words in which two are not together, right? We are creating only those words, excluding the word which have two are appearing together, and then we have to find the serial number or the rank of this word farmer in that list. Now, for solving such type of problems, we have to use basic method only. So the given word is FARMER. This is the given word. And here, first if I arrange the letters in alphabetical order, we'll get A, then we have E, F, then you have M and 2R. Now this word is starting with letter F. In dictionary, first you will have words starting with letter A, then E, and then you will get to F. So let us try to find how many words are there which are starting with letter A and do not have two R appearing together, right? So if I fix A on first place, total we have 5 letters and two of them are identical. So total number of words starting with letter A, this will be 5 factorial, that divided by 2 factorial. But this also includes those words in which two are together. So now we have to remove those cases in which two are together. So A fixed on first place. And now if I want to count how many words are there which have two are together, so then we'll count these two letters as one single unit, right? We have one unit of two identical R, and then we have 3 units of these 3 letters, right? So these 4 units you can arrange on 4 places in 4 factorial number of ways. And also there is only one way of arranging these two R, right? Even if you interchange these two, because the letters are identical, you'll get only one word from there. So the number of words starting with letter A, that is 5 factorial by 2 factorial. But out of those many words, there are 4 factorial words which have 2 R together. So therefore, we have to remove those cases. So now uh, 5 factorial by 2 factorial, 60 minus 24. So total there are 36 words starting with letter A, and those words will not have any 2 R appearing together. Now after A, the word formation will begin with letter E. Now with E also, we have to do the same thing. Words starting with letter E that do not have two R together. So first we'll count total number of words starting with letter E, and then we'll remove those words which have two R together. So starting with E, again if you fix E on first place, 5 factorial by 2 factorial. If two R are together, count them as one single unit. So then we have 4 factorial, and because the letters are identical, there is only one internal arrangement of those two R. So with E, you will get another 36 words, and all these words will come before this word. So first you have A, then you have E, and then after that, the word formation will begin with letter F. So now let us see how many words are there which are starting with letter F. Now with F on next place you need A, and in alphabetical order also you will get A only. So on first place we have F. On second place we got A because that was in alphabetical order. On next place you need R, but before getting R you will get E and M. So first you have FAE, then you will have FAM, and then the word formation will begin with FAR, right? Now with FAE again, how many words are there? So if I fix 3 letters, remaining 3 letters will be MRR. And if I have to ensure that two R are not together, so I mean either you can do that total, you can create 3 factorial by 2 factorial number of words. And if two R are together, then you can create 2 words. So this will be nothing but 1. Or directly also you can see that if you want to arrange these 3 letters and uh, two R should not be together, so that means M must be in middle and R on either side. Similarly from FAM also you will get the same thing, right? M we have to keep in FAM, so you are left with ERR. So E in middle and the remaining two on either side. Or you can say total, you can create 3 factorial by 2 factorial. And if two are together, then two words. So therefore, only one word here. And then after FAM, the word formation will begin with FAR. So now the first three letters FAR. On next place we need M. Before getting M, you will get E. And with FARE, how many words are there? And now remember, you cannot have two R together because one R is here. So now two letters left on two places. You can arrange them in 2 factorial number of ways. After that, you will get FARE, and after E will get M. Other two letters are in alphabetical order, right? So the rank of this word will be, when this word will come on, sum of all these numbers plus 1. So when you add all of these, 72 plus 4, 76, and plus 1, because these many words we have formed before getting to this word. So the rank of this word will be 77, and that should be the correct answer for this problem. So in dictionary problem, you should always know the basic method, because in these type of problem using shortcut technique you cannot solve such problems. So first we start, I mean this word was starting with F, so first started with A, and only those words which have two are not together, right? So total minus two are together. Same thing for A, then E. After that, A we got on second place because that was in alphabetical order, FAE, FAM, and so on. And this plus one is important because these many words we have formed before getting to this word. So the rank of this word will be sum of all those numbers plus one, which is 77. And that is the correct answer for this problem.